Hi there.
See, we are both online now,
I don't want to jinx it. How are you
right?
doing?
I'm good, pretty good. Getting ready for the end of the semester. Being ready for the end of the semester and being ready actively.
Yeah, it is I guess, yeah, next Friday is the last Friday and then we'll have that's finals, right? Friday finals start next Friday.
Yeah, yeah, and I won't even be here all next week. I'll be at a conference, so um, yeah, but ready for a
Any
nice break.
anywhere fun?
What's that?
Are you going anywhere fun for conference?
The conference is in San Francisco.
All right.
Yeah, I've never been. So
Oh,
actually,
cool.
I was there very briefly a long time ago, but um, yeah, it's been a while. Never really
I
explored
got
the city.
yeah, I got to go to a conference there years ago, but I stayed in Japantown and it was so fun to walk around Japantown. And it's just like, of course, a big city like that has something, other cultures.
Yeah, right. That sounds cool. I haven't really looked into it that much. I'm gonna, like this weekend, I'm gonna take some time and look at where we're gonna be. So
Are you
Japantown.
presenting?
No, not this year. We're just going to kind of advertise the program and the center. So I'll be mostly helping Katie man a desk.
Well, cool. I heard
Yeah,
you have two master's students for the fall.
yeah. Hopefully more, but um, certainly Deanna, she's already been working on our project with us, so she's kind of familiar with everything. And then the other person, I think she actually works just down the hall. I think she's a staff here, so she's trying to get her degree.
Yes, I know Christina from San
Christina.
Antonio. Yeah,
Okay,
she's really great.
cool. Yeah, so we're gonna see. We're currently trying to hire a new director, so we're gonna maybe advertise that at the conference as well. Maybe we'll get some interested folks. It'd be really good to get. Um, we had some really good candidates, and unfortunately, it didn't work out for them. So
Oh, so that y'all have been working on it
yeah, and I need
already.
to like repost the job application. Yeah, we've been trying to get someone, but we had this really interesting like culture anthropologist who's out in LA, and she was concerned about selling her house, and I think um, market with that and everything didn't work out.
It is a hard
So
time probably for people to make transitions.
yes. Okay, so there's two of us in this meeting.
There's two of us. I believe it's already being recorded. Yes, they are started
Okay.
automatically. So um we're presenting to the whole world. And I'm very
Okay.
excited.
Okay. Well, I'll go ahead and start the recording then, or the presentation. This is about archaeology. We're training archaeology students and trying to train them in open source programs and open science initiatives. So this is about open education, and because those two things they do come together in really fundamental ways. But primarily what I'm talking about is like the kinds of data tools that archaeologists use in trying to integrate more open source programs in the discipline and into the field. And there's a lot of benefit to doing this. So let's think about this because it can also be applicable to other fields as well, other programs. So in archaeology, just to give a little bit of background, A lot of the students that we get are going to go on. They're probably not going to go into the academy. They're more likely to go into a privatized form of archaeology, often privatized, although you can end up working for the state or the government, doing this as well in various different roles. And this is something we call cultural resources management, or CRM. And CRM is driven by a number of laws, three of the primary ones shown here: the National Historic Preservation Act of 1966, National Environmental Policy Act, or NEPA, and Archaeological Resources Protection Act, and early in the 1900s, also the Antiquities Act. But really starting with an HPA in 1966 really kicked off cultural resource management. And if you go into this field, there's a variety of different things that you have to learn to do to specialize in. Oftentimes, you're learning this on the job because academic programs aren't very good at necessarily introducing students to these skill sets. And we're trying to fill that gap. Various other academic programs are as well. But if you go into this field, just to give you an example here, there's three archaeologists on the right that I know very well. They're all kitted out in all their gear that they have to take with them because they have to do mapping in the field with GIS, GPS, or GLONASS. And they have to do this very rapidly, and they have to take a lot of different data as they go. So they have to record artifacts, information about sites, archaeological sites, information about the environment, and just all sorts of things. And they also have to take good photographs in the field. They need good visual data recording collection. And then once they get out of the field, they have to process all that. So they need to get on and work with GIS, build maps, look at all the GPS points, and manipulate artifact photos, draw maps with vector-based graphics, and manipulate photos with raster-based tools. And then ultimately they need to write a big report. And so what comes out of one field survey, one simple field survey, is actually a pretty large, daunting report. So these take months to finish, these projects do. And these are done around federal lands, anywhere on federal lands where you have a project that can disturb the ground, or on state lands, any public lands due to those laws, or if you have federal or state funding and you're on private land. So those are the places in the United States where you actually do CRM. So in this case on the right, this is likely a vegetation management survey on BLM. That's where a lot of the projects that I was working with these folks was about. And then they may also have to do more specialized things like terrestrial and drone photogrammetry and geophysical prospection. If you watched the first Jurassic Park movie and you remember, they have a like a shotgun shell, and they just kind of create this sonic wave through the ground, and then they see this perfect picture of a velociraptor skeleton. That's geophysical prospection. Unfortunately, it doesn't work like that. It's not nearly that accurate, but you can see kind of patterns under the ground, which is cool. So why train our current students and incoming archaeologists in open? And part of this is directly from personal experience, because when I was a student and graduate student, I learned a lot of things with programs that required a fee, an expensive subscription or fee, such as Adobe, Microsoft, even JUMP statistical analysis is SAS statistical analysis is how I learned to do statistics, unfortunately. And it's quite a powerful program, but it requires a very expensive fee. Agisoft, Metashape, ArcGIS is very frequently used in the field. And I'll get back to ArcGIS in a minute. So a lot of these things may become unavailable to you, and you need open software, and then you have to adapt to learn to use open software. And then if you do learn on open in things that can replace like ArcGIS, it could make you more competitive for the job market moving forward because ArcGIS requires a very substantial subscription, as I said, and that impacts companies that are trying to do CRM. And then there's also reasons having to do with the open science movement. And this is really big. So the open science movement is the one we really want to pay attention to. And this is all about improving data repeatability, speeding up the data analysis, transparency of the methods and the progress in project, sharing best practices, accelerating research. So, and improving rigor by bringing in more diverse voices, and of course, just sharing findings with the public. So what open science, I mean, it's really powerful because it's not just about, making science applicable and available to the public, but it's also about improving methods and actually making the whole process more efficient. So what these scientists are reporting who have been using open methods, who have been putting their projects on like GitHub, including a larger community of scientists around the world who all have access to these open programs, making the process more repeatable, is that actually the whole process speeds up pretty dramatically. So they're seeing really a huge improvement in efficiency, for instance, in this case, protecting the world's oceans with all this complicated data that's collected and needs to be analyzed. So this great article I read from Open Data to Open Science, they say open science is a collaborative culture enabled by technology that empowers the open sharing of data, information, and knowledge within the scientific community and the wider public to accelerate scientific research and understanding. So that's a big drive to train scientists in open source programs and just pursue this paradigm shift in science towards open. So here at Sil-Ross, we've tried to start integrating open. We're preparing for our archaeology program by approving various different open source programs, including even LibreOffice. This is the open source version of Microsoft Office. I use it very frequently now since I lost access to Microsoft Office after I graduated. In fact, I used it to create this slideshow. QGIS, I'll talk more about in a minute. R, of course, is probably like the biggest one in open science, open data science, Postgre, SQL for the same reason, for creating SQL code. Tarot, GIMP, image manipulation program, and same with raw therapy. And then various others. ImageJ is another big one. And we have approved a lot of programs to create and manipulate 3D models. Now, there are some issues with open source that we have to pay attention to. And so I talked with our technology program here, especially Sarah Sheffield here gave me some pointers because I had heard them talking about trying to get these things implemented for our program, that there are various issues. And so there's no vendor accountability, Sarah says. There's no contract or requirement to notify about breach or vulnerability issues. Because the code is often shared, because of code transparency in open software, attackers can actually insert malicious code. And then generally there's fewer maintainers or people who are building and maintaining the software. And so that means that they're less able to keep up with security updates in a timely manner and various other problems that come with that. There's limited official support, lack of routine maintenance, and then kind of bloated architecture a lot of times, and just like various bugs in the program. In some cases, you also get hidden costs, or if the program is actually funded by public donations or that sort of thing, they lose the funding. You can actually lose access to the software completely, or it loses support from maintainers. So there's a variety of problems, and if you start using a lot of open software, you will inevitably run into some of these bugs. Okay, now so to quickly work through what we've done in the past, we've started using open software for photo manipulation, artifact photography in the lab. So I've completely replaced my use of Adobe Photoshop. Now I use GIMP, and you can even get camera controller software for it's open source. So we're starting to integrate that. And then I really want to talk about rapid archaeological reconnaissance or field reconnaissance, because archaeologists are looking at human culture, or the remains of human culture. And if you think about all the different things that humans do, unlike other animals, we leave behind a lot of complex stuff. So the archaeologists are required to go on the field, record this, and to do it as rapidly as possible, because they don't want to be out on a project for a month or recording all the archaeology. They'd rather do it in actually a couple of days if they could. So here we're measuring a projectile point that was found at a prehistoric site. You have to enter the various dimensions of the point, locate its precise position on the Earth, its provenience, and take pictures of it. And all that data needs to be compiled together. And you may have to do this for many different projectile points and a lot of different artifacts on a prehistoric site, and then get back to the lab and have everything put together. And if you don't have a way to integrate all that data together, it can be a huge jumbled mess. In this case, we're recording a cairn. So you can kind of see on the bottom left the ring of rocks with some rocks inside. That's an ancient cairn, place where people cached things, or they're often associated with different kinds of ceremonies that people have done. And on the right, we're digging a trowel test pit. And so we have to record the cairn, the placement of the rocks, photograph it, its size, all the measurements, and then the depth of the trowel test pit and all the information about the soil, different types of soil, colors of soil, texture, the depth and width of the trowel test pit, why it was terminated, if it was positive or not. And in this case, we're recording a feature, what we call a feature. And this one is a stone hunting blind on kind of a bottleneck on the landscape where animals, if they were going up this draw, they were forced to kind of go along this little bench, along this ledge. And probably Ute people in Western Colorado constructed this hunting blind. And we don't know how old it is, but we took pictures showing that the lichen bridges the rocks, indicating that it was constructed a long time ago before the historical period. So we have to record, we have to take lots of pictures, record all the measurements, its precise location on the Earth, that sort of thing. And then we even have to do historics. So we have to talk about cans and glass and structures and all sorts of things associated with that.
Sorry to interrupt you.
Yep.
Dr. Pettigrew, I think that the slides got lost as you were pointing out some of those photos. If you just want to maybe catch up to wherever you are, I'm sorry about that.
Okay, so where did we lose at? Where did we get lost at?
When you were talking about when you went in and you said something was in the lower left-hand corner, I don't know if I think the slide like got started from the top. So, but if you just want to start from where you are.
Okay, what can you see right now?
Just the front page, like the first slide.
All you can see is the first slide?
Yes. Okay, now I see rapid archaeological field reconnaissance.
Okay, did you see this? Any of this?
Yes.
Okay, so we just got lost here.
Yes. Okay, awesome.
Okay, and can you still see it?
The rapid archaeological field reconnaissance is what I see right now. Okay.
Yeah, so this is the cairn I was talking about, and the trowel test pit. And then can you see the feature here that's a stone alignment?
Yes. Yeah. Mm-hmm.
Okay. All right. Sorry about that. I don't know what various technical issues today. It could be, and so I have created this slideshow, remember, in Libre Impress, which is not there are various bugs. If you try and use it, it's an open source program, and it's quite good actually. But there are things that really make you scratch your head sometimes, trying to figure out. Okay, so as I was saying, there are various cons with open source. Now this is the GIS program QField. Can you see the QField screen capture?
No, it seems like it's getting stuck on slides. I'm still in that wrap here. Now I see it. Yes.
Okay, I'm going to just leave it not on the slide view. Okay, let's see. Make it a little bit bigger. Sorry about that. Okay, so this is actually QGIS, and apologies for the big complicated screen capture, but what it shows is that this is a big complicated program for GIS. It's actually quite powerful. And the arrows on the left are pointing to the geo package. This is the geo package project that we've made. And then on the bottom, the layers, the point, line, polygon. So these are all the different kinds of things that we can map in this program. And I've compiled it all together inside of a geo package, which is a nice, tight little thing that you can share and easily replicate without having like a big complicated file full of all these different layers and that sort of thing. And within this program, we can do quite a lot. So go to the next slide. There we go. And can we play our video? Okay, so this is QField, which is the mobile application associated with this program. And within QField, in this app that I've created within, QField is, kind of the vendor, open source vendor for this program. And you can do a lot to kind of fix it as you want, right? So we can create points, lines, and polygons. And within each of those, you can enter all sorts of data. You get an automated field number that comes up with each record. You can capture QR codes for labels for artifacts, and you can even take pictures. And so all of that data I was talking about can be captured all within one program. And when you get back to the office, you can pull all of this off of the cloud. It updates to the cloud. You can pull it all off straight into QGIS and pull out tables where everything is associated together with different sites and projects, and you can find the specific photographs that go with each artifact and that sort of thing. So, so it's quite powerful and completely open software, and that's great because how I learned to do this was on proprietary software that was developed by a company that I worked for in Colorado, and it was quite complex. So there were had to deal with. And then that company ultimately got bought out by a corporation that was primarily interested in their proprietary software. Millions of dollars, apparently, I was told. So, so now the idea is to make this available to the public. So the next steps now are to share this with broader archaeological community. I need to connect with a network of GIS and open specialists to really make this happen. And this is part of the purpose here to make it open is to actually get feedback, to improve, and to make this something that a broad range of the community population can use and kind of implement regular standards. And it's all free. So, so that's it. I think I've probably talked enough and cut it off there. Thank you.
Thank you so much, Dr. Pettigrew. But I find that super interesting. I've heard a little bit about your work, and I've been personally trying to learn QGIS. It is a steep learning curve, as you pointed out to me.
Right.
But what you've done with it is super cool. I'm kind of curious just to have a question. You have right now the Office 365 licensing as an employee of the university, but have you just trained yourself to kind of put yourself into these open situations, and that's sort of kind of a philosophy you're living by at this point?
Yep. After I lost access to a lot of that from after I graduated, that was so jarring, and it impacted me in really negative ways because I had to relearn a lot of skills. I had to reacclimate to all these different programs, especially with statistics. All the statistical analysis I did in JUMP, I had to relearn all that in R. So that was terrible. So there's a very good reason to train people in this stuff, and then to keep using it and just be familiar with it as an instructor so that you're ready to teach people in it. And I'm not going to tell you don't use Microsoft Word. I use that very frequently. Although actually the Libre Word program is really quite good, but there are some issues with sharing across collaborators and making reviews and edits and that sort of thing between Libre and Microsoft. But I try to use this as much as possible. The Libre Calc I use for all my data purposes, all my tables and everything. Yeah, I really prefer a program called PDF Exchange Editor instead of Adobe, but we haven't approved that one yet.
Well, and thank you for doing the work with our Office of Information Technology too, to get some of this stuff approved and creating the precedent for open at Sul Ross. That's wonderful.
Yeah.
Well, thank
absolutely.
you again. Yeah, thank you for your presentation. And I guess, I rarely record things, so I think all we have to do is stop this recording and mosey over to the closing keynote. But thank you again for taking the time today.
Absolutely. Okay, thanks, Betsy.
Thank you.